In this module, we will discuss about the documentation available to dispatch an ETOPS flight, the specific definitions used during dispatch, and the dispatch of an ETOPS flight itself. The information and procedures related to ETOPS operations are available in the airline documentation, such as flight manuals, maintenance manuals, and other appropriate documents, such as CMP. The information and procedures related to ETOPS operations are available in the airline documentation, such as the CMP is customized according to the operator's fleet and certified by airworthiness authorities. It defines the configuration of the aircraft, the specific maintenance requirements, the specific procedures, and the dispatch limitations. The CMP contains a list of items under a specified form. Roll your mouse over the fields to get additional information. As part of the documents is also the ETOPS Significant Systems List. Based on manufacturer data and its own experience, an operator defines a list of systems that are considered as important for ETOPS operations. These systems require an ETOPS reliability monitoring. They are categorized in two groups. Group 1 designs the systems that may be affected by an engine failure, and Group 2 designs the other systems that counts for ETOPS reliability and maturity operations. The part list is a non-approved document to assist the operator in the identification of the part numbers not approved for ETOPS. It must be considered as a tool only, as the CMP should always be used as the reference. The manufacturer also provides the ETOPS compliance document, ECD. This document lists the items that have been incorporated or retrofitted to the aircraft design to be compliant with ETOPS requirements. This is the responsibility of the operator to establish pre-flight and dispatch procedures. They must be described in the operator's operations manual, OM. The Airbus ETOPS checklist that we will use in this course is an example of procedure, but each operator normally establishes its own. And the flight crew documentation for the intended flight should include a computerized flight plan, CFP, with a copy of the ATC flight plan, a navigation and plotting chart, with the ETOPS relevant information, airport charts, MEL and CDL ETOPS capabilities, and other relevant documents such as NOTAMs, weather forecast and diversion strategy. Prior to discover the different steps of an ETOPS flight dispatch, we will define some important useful terms. Previously, we defined what was an adequate aerodrome. A such aerodrome satisfies criteria on performances, approvals and ground services. For dispatch purposes, we need to select an ETOPS en route alternate aerodrome, ERA. the ERA must be an adequate aerodrome, which satisfies the ETOPS dispatch weather requirements, in terms of ceiling and visibility. And this, within a period of validity called time window. We are going to describe the ETOPS weather requirements later in this module. As a reminder, at the beginning of the ETOPS sector is the EEP, and at the exit is the EXP. The ETP stands for Equal Time Point. This is the point of equal flight time between two diversion airports, considering wind and temperature effects in OEI conditions. It is also defined as the point at the furthest air distance from a pair of ETOPS alternate airports. Without wind and with the same temperature in both directions, the ETP is the midpoint between both airports. If conditions are different, the ETP moves forward the most adverse conditions. Before the aircraft reaches the ETP, the nearest diversion airport is the first one, as after the ETP the second one is the nearest. One of the ETPs of the route is considered as a critical point, CP, with regard to ETOPS fuel requirements. A diversion at the CP is the least favorable for fuel planning, according to the considered failure cases which will be described later. The CP is usually, but not always, the last ETP within the ETOPS segment. Therefore, it is necessary to carefully determine the CP by computation from ETOPS fuel scenario applied to each ETP. The time window, also called period of suitability, is defined from the earliest and the latest estimated times of arrival, ETAs, at the diversion airport. The earliest ETA at an alternate airport is the departure time, plus the normal flight time to reach the first ETP to the considered alternate airport, plus the diversion time from this ETP to the airport at normal cruise speed and flight level. And the latest ETA is the departure time, plus the normal flight time to reach the farthest ETP to the considered alternate airport, plus the diversion time from this ETP to the airport at long-range cruise speed and flight level 100 or more. The time window starts from the earliest ETA and ended 1 hour after the latest ETA. The time window is based on the estimated time of departure. If the dispatch of the flight is delayed by more than 1 hour, the time window must be adjusted accordingly. For example, this flight is scheduled to depart at 9:20 Zulu. The flight time to ETP1 and ETP2 is respectively 2 hours 21 minutes and 5 hours 12 minutes. The alternate airport is respectively at 2 hours 20 minutes from ETP1, and 2 hours 43 minutes from ETP2. Thus, the time window at the diversion airport goes from 14:01 Zulu to 18:15 Zulu, as into account the 1 hour margin after the latest ETA. Now, let us see additional data regarding dispatch, as we are going to prepare a flight with an A330 from Shannon to New York. On the chart, we see that the expected route is beyond 60 minutes from a suitable airport. So, the flight will be operated under ETOPS requirements. Also, this flight preparation is accurate regarding requirements needed for a such flight, such as a VSM, North Atlantic high-level airspace, oceanic crossing. But we are not going to discuss about these items. Please, find in your ETOPS documentation the ETOPS dispatch checklist at your disposal, and jump to the next screen when ready. the first step is to check the ETOPS status. We consider that the crew and the company is approved for ETOPS flight on the considered route. The maintenance department released the following statement for the aircraft. With the help of the ETOPS significant system list, identify the potential consequences on the aircraft status. Also check in the MEL, what are the consequences of the APU failure on the ETOPS capability. Click on the screen when ready. According to MEL, APU can be inoperative provided that ETOPS beyond 180 minutes is not conducted. As per our flight is intended to be conducted under ETOPS 120 minutes rules, this has no consequences on the route. But an MEL item could lead you to rework the route. For example, with a such MEL item, we observe that no ETOPS flight is permitted. The route must be modified accordingly if the problem cannot be solved. Then, check the NOTAMs. For departure, destination and alternate at destination airports, and for ETOPS adequate airports approved for the intended route as well. For each adequate airport, the dispatcher must check that for the time window, the airport is open or can be open upon request, and one or more instrument approaches are available. In our case, our ETOPS adequate airports of Cheonan, Keflavik and Gander are good for dispatch. But are these airports suitable, and thus be qualified as ETOPS en route alternate? We must determine if weather conditions are consistent with ETOPS weather requirements in the time window for each ERA. These requirements are more restrictive than the normal weather minima, to ensure that an instrument approach can be safely performed. The following table gives the requirements according to the approach type. The criteria are not applicable to Cat 2 and Cat 3 approaches, except if approved by the NAA with the following requirements. The aircraft is Cat 2 or 3 approaches capable in OEI conditions, and the operator is approved for Cat 2 or 3 approaches. These minima apply only for dispatch. After dispatch, normal minima apply. In addition to the ceiling and visibility criteria, the following items must also be checked for each alternate airport. The forecast surface wind including gusts, and the condition of the runway expected to be in use. Crosswind and tailwind limitations are available in your documentation. Be aware that you need to take into account magnetic variation for the computation, as where the forecast surface wind is in degrees true. Also, any conditional forecast item must not be considered, except for tempo and Prob 40 conditions, where only deteriorations below the applicable operating minima must be taken into account. The operator must provide the weather minima criteria in the operating manual. Please find in your FCOM this dedicated part, then click on the screen when ready. This is available in the chapter Procedures, Special Operations, Extended Range Operations of the FCOM, in the Dispatch Consideration, Weather Minima part. The minimum weather forecast for ERA must always meet the operator's applicable weather minima requirements. At the dispatch level, the operator uses an ERA selection form. From a pilot perspective, the selected ERA are displayed on the CFP. The ERA selection form enables to summarize the studies performed previously. Data relevant to each adequate airport are listed to know if it can be retained as an ERA. For example, one of our adequate aerodrome approved for our route is Gander, Charlie Yankee Quebec X-ray. Approach charts for Gander and the weather forecast are given. According to the dispatcher, the time window for Gander Airport is the following. On the ETOPS ERA selection form, the ceiling and visibility minima for the runway 03 and runway 21 approaches are filled, as well as the respective dispatch minima. According to NOTAM, there is no restrictions regarding approaches on runway 03 and 21. The forecast wind including the gust must be within the operating limits, taking into account the runway conditions. As there is no forecasts for breakwater policy, must be based on the available SNOTAMs, and the METARs and forecast analyses. The wind indicated in the TAF is related to true north. Runway orientation is indicated on the form, either related to magnetic north, either related to true north to help you. The forecast wind indicates that runway 21 is planned to be in use in the time window. As the crosswind and the tailwind components are within the limits, Gander can be designated as an ERA airport. The same methodology must be applied to the other runways and adequate airports. As this course focuses on ETOPS aspects, we are not going to deal with the other items of the flight preparation. Keep in mind that you must also take into account the various navigation requirements encountered on your route. RVSM airspace, North Atlantic high-level airspace. North Atlantic, Pacific, Australian, China, airspaces. Polar airspace. ANAV, and CAT 2 or 3 approaches. Once the routing aspects are solved, you need to draw your route on a plotting chart with all the ETOPS specificities. Usually, the dispatcher prepares the plotting chart with the following details. The intended routing. The ETOPS area of operation, defined by the circle centered on the ERA airports. The EEPs and EXPs, that define the ETOPS sectors, and the ETPs and the CP. The dispatcher also provides a computerized flight plan, CFP, including all the ETOPS corresponding data. The CFP is divided in several sections, some of which are common to non-ETOPS flight. A first part is dedicated to the summary of the flight. In a second time, you have the selected ERA airports with computed time windows. A third part is dedicated to the detailed routing with alternates, coordinates and ATC flight plan. Finally, a last part describes ETOPS data. The flight crew must cross-check the CFP to detect any possible gross error on the aircraft type, the date, the routing and the estimated time of departure, ETD. The estimated zero fuel weight, takeoff weight, and fuel on board. The wind data compared to the weather forecast, and the fuel data. The flight crew must check the minimum safety altitudes, MSA, along the route, and along the route from the ETPs to the ERA airports. This will help the crew to foresee specific diversion profiles, in case of any significant obstacle along the routes. Specific data related to ETOPS are embedded in the routing of the CFP, EEP, ETP, and EXP. The full coordinates of this ETOPS specific points are given later in the CFP with the other waypoints coordinates. A large part of the CFP is dedicated to the fuel quantity computation. First, we are going to see the fuel requirements for an ETOPS flight. To dispatch an ETOPS flight, a dispatcher must determine both the standard and an ETOPS fuel planning. Then, he selects the one which requires the highest fuel quantity. The operator must use weather forecast, cost index and an aircraft performance factor to compute a realistic fuel planning. The performance factor reflects the deterioration of the airframe and the engines. It must be determined for each aircraft of the fleet, based on an aircraft performances monitoring program. The ETOPS fuel planning takes into account two parts: the fuel to fly from the departure airport to the CP, and the fuel to fly from the CP to the diversion airport, which corresponds to the critical fuel scenario. The critical fuel scenario is based on a study of 3 different failure cases for each ETP. The engine failure scenario, the aircraft depressurization scenario, and the engine failure associated to an aircraft depressurization scenario. For each scenario, the diversion profile is the following: a descent at a predetermined speed strategy, to the required flight level. A cruise phase to the diversion airport at the predetermined speed. A normal descent down to 1,500 feet above the diversion airport. A hold for 15 minutes at 1,500 feet above the diversion airport, and an instrument approach. In the engine failure scenario, the descent is performed at MMOVMO, down to the OEI optimum flight level, and the diversion cruise speed is the one selected for the area of operation determination. In the aircraft depressurization scenario, an emergency descent is carried out down to flight level 100 or more, and the diversion cruise is performed at long-range cruise, LRC speed. A diversion above flight level 100 may be necessary to clear obstacles with the required margin, if the aircraft is equipped in accordance. In the engine failure with aircraft depressurization scenario, an emergency descent is carried out down to flight level 100 or more, and the diversion cruise speed is the one selected for the area of operation determination. A diversion above flight level 100 may be necessary to clear obstacles with the required margin, if the aircraft is equipped in accordance. The first scenario is never limiting. The OEI ceiling is higher than flight level 100, thus the aircraft fuel consumption is much lower than in the two other scenarios. ETOPS requires additional fuel reserves. A 5% fuel consumption penalty, or a performance factor penalty of the diversion trip fuel. A contingency fuel which corresponds to 5% of the fuel required for the diversion, if the forecast wind is not taken into account, or 5% factor on the actual wind speed, if approved forecast wind model is used. The APU fuel burn if required. A penalty corresponding to the MEL and CDL effects, and a compensation for the icing effects. As the ice accretion on the airframe and the use of anti-de-icing systems increase the fuel consumption, this has to be taken into account. The compensation for icing effects corresponds to the additional drag due to ice accretion on unheated surfaces, plus the wing anti-ice and nacelle anti-ice systems operation, during 10% of the forecast icing time, or the wing anti-ice and nacelle anti-ice systems operation during 100% of the forecast icing time. On Airbus aircraft, this is the last case the most critical. The scenario that requires the highest fuel quantity is considered as the ETOPS critical fuel scenario. The associated block fuel quantity is referred to as the ETOPS critical fuel planning. Also, the associated ETP is named as the critical point. Note that NAA may request additional fuel reserves during the ETOPS approval process. Then, the dispatcher compares the ETOPS fuel planning with the standard fuel planning. The highest is considered as the required block fuel for the flight, and thus ensure the flight crew to complete the flight whatever the scenario. A part of the CFP is dedicated to the ETOPS detailed data. Firstly, the diversion conditions are given. Then, for each ETP, you have the following data: the position of the ETP, the flight time and distance to the ETP, the estimated aircraft weight and fuel on board at the ETP, the scenario considered, the conditions to fly to the diversion airport, and the required fuel quantity to reach the alternate.